Hello everyone, my name is Jiakang Li, and today I'm gonna present a model for predict diabetes. So first of all, our project goals. So we all know that diabetes has been a serious illness around the modern society in today's world. Almost 540 million people from age 20 to 79 are living with diabetes. This causes them a lot of pains by injecting insulin every day and also suffering from some urine issues. So our goal is to build a predictive algorithm for which factors will cause diabetes, which will help the doctors and a healthy institute to better predict which kind of person will get diabetes, or in a fast-paced manner to cure diabetes. So we have observed a dataset that contains factors as a pregnancies, glucose, blood pressures, skin sicknesses, also insulin levels and BMIs, also diabetes pre-degree functions, which is family histories of diabetes, also age, and also the outcome, which is whether they have diabetes or do not have diabetes. So we have decided to use SAS Enterprise Miner to build our models. On the left-hand side is our project life cycles with its functions and node we have built in SAS Enterprise Miner. And then on the right-hand side is our project phases. We have divided the entire project into 4 distinctive phases. First one is data obtains, which is we get the data and transform the data into a useful manner to import in SAS Enterprise Miners. And second is data cleaning and pre-processing, which we manipulate the data, trying to find missing values and outliers and clean them, which is help us to do more efficient model buildings for our future process. And third is our model building, which is we choose 3 models that we want to use to build the prediction models. The 3 models we choose are logistic regressions and decision trees, and also random forest. Also the result analyzers, which we will compare the 3 models to decide which one is the best model for us to use in the futures and also for our test. So here is our data obtain and exploration stage. We decided to use National Institute of Diabetes and Digestive and Kidney public datasets to build our prediction models. From our file import from SAS Enterprise Miner properties, we have changed the outcome to a binary levels and as our target variables, and also all other variables to be an input and also interval variables for us to better predict the outcome that affected by other variables. So here is our data cleaning and pre-processing stage. We're doing this stage because it could help us to improve the quality of the dataset and also improve data efficiencies. We can see on the right upper corners that we have set up the minimum frequency cutoff to 1 and minimum cutoff of percentage to 0.01 at our data filter functions in SAS miners. And by doing that, we could eliminate those negative values or even outliers from the dataset. And we can see on the right down corners that we have eliminated almost 80 variables from the dataset, which is sometimes negative or missing values. Here is our exploratory data analysis stage, which we use a multi-plot to see the distributions of all the variables that over the outcome. We have picked up 6 variables that have significant effects over the outcomes. So based on the graphs, we conclude the following group may have a higher chance to have diabetes. First of all is age from 30 to 55, and also blood pressures between 60 mmHg to 88 mmHgs, and also having lower insulin levels. Also more than 7 pregnant people would have more chance to getting diabetes. Also, skin fold sicknesses between 0 millimeters to 5 millimeters people would have a higher chance to have diabetes. And also, most importantly, high glucose concentration in a person's body could indicate that a person may have a chance to have diabetes in the future. Now it's our model building stage. So before we're doing any model building, first thing we have to do is a validation set, which we could done it in data partition as SAS minors. So first we set the training data as 80% of the entire dataset and 20% for validations in the data partitions. By doing this, we could prevent overfitting and underfittings from the models. So what is overfitting? Overfitting happens when we train the model too much that the model would get the result that really close to the training dataset. What is underfitting? Underfitting happens when we treat the models too less and the model could not accurately obtain the right relationship between each variables. Both of this come with the data noisy, which would prevent us to get an accurate result for our models. So this is why we need to do a validation set before any model buildings. Now it comes to choosing models. We have to choose 3 models that we would performance in our model predictions, which at the end we will choose the best models for us to implement in the futures. The first one is random forest. Random forests or random decision forests are an ensemble learning method for classifications, regressions, and other tasks that operates by constructing a multitude of decision trees at training time. Second, logistic regressions. It is a statistical analysis used to predict a data value based in the dataset. It could predict the independent variables by analyzing the relationship between other independent variables. Third, the decision trees. So the decision trees is a non-parametric supervised learning method that is used for classifications and regressions. Decision trees could use learning samples to create models that predict the value of the target variables under each conditions and also requirements. After we construct the 3 models, now I come to compare the model's performance and the result analysis. So after we see the result in the model comparison at SAS minors, we could see that on the EOC chart, random forest model is more sensitive than other models that predict for our predictions. And looking at our score ranking overlay graph, random forest has the highest cumulative lift, which much better performance than the other 2 models. Also in the fit statistics, random forest has the lowest average square errors, which means that it has a lower errors for the prediction result, which means that a random forest would be the best model for us to adapt for our future test. Now let's come to the advantage and the limitations of random forest. So the advantage of random forest is that it's a vast algorithm compared to the others. It is easy to view the importance of feature input, also could reduce overfitting problems that may occur in the decision trees. It also could reduce the variance of the models, and also it will automatically handle the missing values. There's also limitations for the random forest. It requires longer time to process. It need high space capacities. Also, it takes longer time to train the model, also longer time to validate the model too. And finally comes to our conclusions. So from this project, we have learned that people that are around 30 to 50 years old with blood pressure between 64 mmHgs to 88 mmHgs and also has less insulin levels and also have a large amount of glucose concentrations in the bodies would have a higher chance to obtain diabetes. Also, by implementing the random forest prediction models, doctors and health institutions could successfully predict if a person will have diabetes in the future and better to prevent it from happenings. So our models still have a lot of space to improve since our dataset is only a small dataset. We believe if we could use much more large and a more informative dataset, the result could come much more accurate and the model would perform much efficient. And thank you very much. That's all my project, and have a nice day.